Welcome to our first presentation in Explorations in Mathematics, Math 131. In this presentation, you will be introduced to the basic terms we will be using in our first unit on graph theory. Now, I'm sure you've done quite a bit of graphing in your previous math courses, but in Math 131, we're going to be looking at very specific kinds of graphs, graphs that only consist of vertices and edges. A vertex is a point, and we will use both closed points sometimes and open points. Doesn't matter. Then we will have some edges, and the edges are any curves or lines that connect two vertices. We don't care which we use, and the same graph can be represented two different ways, some using curves, some using lines. So we're going to go through a few examples now. Here's our first example, and our first example consists only of the vertex A. Notice that there are no edges, and this is perfectly acceptable. We can have vertices with no edges, but we cannot have any edges with no vertices. Any edge has to have a vertex on both ends. So here's our second example. It consists of three vertices, A, B, and C, and it has two edges. The edges are AC and AB. Notice that I can also call the edge AC CA, and I can call the edge AB BA. When I'm naming an edge, it doesn't matter which order I write the vertices in. So we can have two vertices that have a common edge. If we do, those vertices are said to be adjacent. So again, for this example, you will see that A and B are adjacent because they share an edge. Also, B and C are adjacent because they share an edge. However, A and C are not adjacent because there is no single edge connecting A to C. Two edges can also share a common vertex, and those are also called adjacent. So here we have AD is adjacent to CD because they share the vertex D. BC is adjacent to CC because it shares the vertex C. Now notice I just called an edge CC, and we're going to look at that next. That's called a loop because it has the same vertex at both ends. So CC is a loop, and we repeat the vertex to show that it is a loop. Notice again also on this same graph that we have two edges that connect A and B. So these are called multiple edges. Multiple edges are any time two or more edges have the same endpoints. So AB names two different edges for this graph. That makes AB a multiple edge. Now, we want to turn to looking at the degree of a vertex. The degree of a vertex is the number of times an edge comes into that vertex. Frankly, this is a lot easier to give you examples of than to define. So let's look at an example. Let's start with the vertex A. You're going to notice that there are two edges going into A, AC and AB. Therefore, the degree of A is 2. Now, you can test yourself for a moment. What is the degree of B? Yeah, you got it. It's 1 because there's only one edge going into B. Now, the degree of C is a more interesting question. Clearly, we have CA meeting up with C once. Good enough. But now we have the loop CC also meeting up with C, and it meets with it twice, one on each side. So that means that C has the total degree of 3. 1 for the edge CA and 2 for the loop CC. So for our very first example, what would be the degree for A? Well, we don't have any edges at A, so therefore the degree is going to be 0. So take a moment and see if you can find the degrees for each of these vertices, and I will wait to give you a little time to think. So, the degree for A would be 0. The degree for B will be 3, because we've got those 3 edges. The degree for C is going to be 4. And the degree for D is 4. The degree for E is 2. And the degree for F is 3. Now this graph gives us another instance, another term we need to look at. And that is the fact that notice that A is not connected to the rest of the graph by an edge. So therefore, we call this a disconnected graph. Anytime we have a disconnected graph, it's because we have more than one piece. This one has 2, and we call each of those pieces a component. So now, take a look at this graph. For this graph, we actually have 4 components. We can have as many components as we wish, but anytime we have more than one component to a graph, it's called disconnected. A graph with only one component is called connected, and frankly, for most of our chapters, we're going to be considering only connected graphs. Finally, we reach the last idea we need to look at, and our last 2 terms, odd and even. If a vertex has an odd degree, we're going to call it an odd vertex. And if a vertex has an even degree, we're going to call it an even vertex. In your next class project, when we meet again, you're going to be filling out a table identifying how many even vertices and how many odd vertices any given graph has. So let's give a try to categorizing some vertices before we finish. For this graph, we've already said that A has 3 edges going to it, so it is a degree 3. And therefore it's going to be an odd vertex. B also has 3 edges, so it's an odd vertex. C has degree 4, and so therefore it's going to be an even vertex. And D is degree 2, so it's also even. So for this graph, we have 2 odd and 2 even vertices. Well, that finishes the terminology for Chapter 5. You're now ready to do the MyLabs Plus Homework 1. Remember that I use MLP as shorthand for MyLabs Plus. Please log into MyLabs Plus and go to the assignments. You'll find MyLabs Plus Homework 1 just under the orientation homework from last week. And it's going to consist mostly of questions that are based on this presentation. You're going to want to earn a 90% on that homework, and then the system will open up and allow you to take quiz 1. If you see a green flag on quiz 1, that's because you don't have a 90% on homework 1 yet, and you need to complete that before you're allowed to take the quiz. Quiz 1 will be the same types of questions that are on the MyLabs Plus homework 1. Please be sure that you check Blackboard under week 2 to see when MyLabs Plus Homework 1 and Quiz 1 are due. And thank you very much for listening to this presentation.